Today I'm going to talk about testing diodes with a old type volt ohm meter, or if you want analog multimeter. You can make the test in circuit, but it's going to be more reliable if you remove the diode or if you connect one of the leads from the circuit and then do your measurement. I always start out by setting the ohm meter function of the multimeter to the R times 10, basically R times 10 range. And what we want to do here, this is a 1N, I believe, 4148 silicon diode. What we want to do here is connect the red probe to the anode and the black probe to the cathode. Now this depends, because like some of the old time ohm meters, it would actually be reversed. Now they would be using the red test lead. It would be for to measure the positive voltages, and of course the black being the minus. But if you use the ohm meter function, it could be the other way around. So basically you'd probably be best to check it with another meter. So as I said, we should be connecting the black end to the cathode, the black test lead to the cathode, and the red one to the anode. Of course, there's a little mark on here, so you can basically see that. Now what happens is when we connect the red probe to the anode and the black probe to the cathode, is that the diode becomes forward biased, so it's going to pass current. So you should read a fairly low resistance. I think I'm reading about like I'm on the R times 10 range, so I think I'm reading like 90 ohms. Now this can vary. It just depends upon the diode, and also it depends upon your meter range. The important thing is that the diode has a low forward resistance and a high reverse resistance. That is basically what counts. So when I reverse the leads, that should give me, according to theory, high resistance, which it actually does. Now, if it were to have a high resistance in both directions, then you can basically say that the diode is open. And right now I've got the diode basically reversed, hooked up the reverse way. It's reversed bias right now, so I'm basically reading a really high resistance. Now if I were to have like a, let's say, low resistance in the reverse direction when I've got the leads reversed, that means I could basically say that the diode is leaking. That means, of course, that more current is flowing in the reverse direction than it's supposed to. Basically, you have a leak. I mean, there's always some current flowing in the reverse direction, but that's minimum. I think it's going to be like on the order of microamperes. So that's why you have a very high resistance in the reverse direction. And of course, if you have a really low resistance both ways, like it's, like I had earlier, it was 90 when it was forward biased and 90 reverse biased, and basically if you have a situation like that, or a lot lower resistance in both ways, you can basically see that the diode would be shorted. Now I'm going to try one more. I think I'll try I need to get this diode out of the package, so This diode here, I believe this is a 1N60. That's a germanium diode. Of course, here you probably can't see, there's a marking right there. That's the cathode, of course. So do the same thing again. I'm going to start out with the red lead on the anode, black on the cathode. So okay, getting a fairly low forward resistance. Now we'll go back, and I'm getting a high resistance. So I could basically say that this diode is good. Of course, some diodes, they break down when they're operating at their rated capacity in the in circuit. So there is always a slight possibility that you could test the diode this way and it'd actually still be bad. I always like to use, I have a special diode and transistor checker, semiconductor checker. That's what I normally use. But this can also, it could be done basically in most cases this way too.